Hello, Dr. J here. We're going to get started with some basics in electrical engineering. What I'll be talking about today are two important electrical engineering variables, namely voltage and current. We're also going to see how these electrical quantities are related to power and energy. Also, we'll briefly see what is meant by a schematic or circuit diagram. With voltage and current, you can psychoanalyze the behavior of circuits. Now, before getting into these definitions, let's take a look at the voice or music coming out of your smartphone. You can treat the music output of a smartphone as an audio signal. In the engineering world, you can describe these signals in terms of electrical variables. And you guessed it, it's voltage or current. We'll see later how device voltage and current behaves in a circuit in later videos. So let's get going with the flow of current. Current is a measure of the amount of charge passing through a given point within a certain amount of time. You can think of current as a flow rate. This is analogous to water flow rate having units of gallons per second. Now, for current, the flow rate is described as coulombs per second or amperes. Instead of gallons describing the amount of water, you have coulombs to describe the amount of charge. Now, 1 coulomb has 6.28 e to the 18th electrons. A humongous amount of electrons, or taking the reciprocal of this amount, you have 1 electron is equal to 1.6 times 10 to the minus 19th coulomb. And we should also note that an electron is a negatively charged particle. So there you have it. Current is described as the flow of charges with units of amperes or coulombs per second. Now in engineering, the current direction has a net flow of positive charges. And you can think of current as a through variable because the flow of electrical charge passes through a point in the circuit. Now to measure the current through a device requires 1 point of measurement. As an analogy, say you and your neighbor overlook an interstate freeway. You are asked to count the number of cars flowing through the interstate between exits for several minutes. You can count the number of cars from your home. Your neighbor also counts the number of cars, but from his point of view and looking at a different point on the interstate. You both should come up with the same number of cars. In other words, you just need 1 point to measure the flow of cars. And this is true for an electrical circuit. So if you want to measure the flow of current, you just need 1 point in a circuit to measure the current flow going through a device. Now there exists 2 types of current, alternating current or AC and direct current or DC. With AC, the charges flow in both directions, just like in a two-way highway. With DC, the charges flow in just one direction, just like a one-way street. A battery is an example of a DC source, and the power coming out of your outlet in your home is an example of an AC source. Current or electric charge flow is sloshing back and forth in a circuit or in an electrical device. So if you have trouble keeping AC and DC straight, try this mnemonic device. AC means always changing, and DC means doesn't change. Now there should be a short quiz following this video that you should take before I give a short video on measuring current using a circuit simulation software. Now if the video is posted on YouTube, there should be an icon link to take the quiz in the upper right hand corner. After that video demo on measuring current, the next topic is voltage.